Okay, this next unit we're going to work on operations with functions. It's going to sound a little weird, but all we're really doing is what we just talked about with adding, subtracting polynomials, adding and subtracting radicals, that kind of stuff. It's the same, we're just putting some mathematical notation behind it. For example here, if we want to add and subtract functions, for example, if I had f of x equals this parabola, g of x equals this cubic right here, and I asked you to find this. All that is mathematical notation that says take this function and put a plus, and then put this function, and then simplify using all the procedures you've learned before. So that's the key to these, is recognizing that when it says to find the sum of two functions, f plus g of x, that means take f of x and add it to g of x. Same thing with minus. When I say f minus g, I'm talking about take the first function and subtract the second function from it. And then subtract, there's always that distributing the subtraction part, and I'll show you in this example. So if f of x equals x squared plus 2x minus 1, then when I come down here, this means take f of x plus g of x. Well, f of x is x squared plus 2x minus 1 plus g of x, and g of x is 3x cubed minus 4x squared plus x. That's exactly what we were just talking about on adding polynomials, right? Now we look for common like terms. These guys and these guys are similar. 3x cubed, nothing, so he's going to have 3x cubed minus 3x squared plus 2x plus 3x altogether, and then minus 1. And this right there is f plus g of x. That's the actual function that's formed by adding those two other functions together. Okay, over here we've got f minus g, which literally means take f of x and subtract g of x from it. Okay, dealing with the same functions, this guy right here, x squared plus 2x minus 1 minus g of x, but you have to remember when you're dealing with subtraction that there's that one little guy that means you've got to distribute. Whoops, didn't mean to draw that guy. That negative has to be distributed through before you can do any further multiplication. Sometimes there's no distributing into. That happens mostly with polynomials, but don't forget to distribute that guy through. So now it's actually x squared plus 2x minus 1 minus 3x cubed plus 4x squared minus x. And again, to add and subtract polynomials, you look for similar terms. These guys, these guys. So it's going to be negative 3x cubed. This time we have plus 5x squared plus 1x, and then minus 1 at the end. So this one right here is f minus g of x. All right, then the second part says to evaluate. Now, just as a reminder, what evaluate means take in the given value and plug it in. Plug it in. Another way that it's sometimes written is f of a number, right? F of 2. That means plug 2 into f of x. So this one says to evaluate both, referring to these two up here, when x equals 2. What that's essentially asking for then is to find f plus g of 2, and all that means is take that x out and replace it with a 2. And simplify. You can even do boop, boop, calculator says. Okay, for this one, I got f plus g of 2 equals 17. Check my math. Right, this one over here, if I want to find f minus g of 2, I'm going to take my new function, and everywhere there's a x, I'm going to plug in a 2. And then after I plug that in, if I'm correct, as long as I didn't make any math errors, f minus g of 2 equals negative 3. Check my math. Email me if I made a mistake. Okay, here's two new functions. Now these ones have radicals. So we've got to remember what the rule is for when you add or subtract radicals. You just look those up. Did your little activity to remind yourself. So f plus g of x, all that means is f of x plus g of x. Again, I want to stress that f plus g of x equals this is not quote-unquote distributing x into that new function. This is creating a new function made up from combining two previous functions. So it's not distributing. Don't think of it as distributing. You'll end up getting tripped up later on. So f of x is 3 square root of x plus g of x is negative 10 square root of x. Applying the rules for radicals, that becomes negative 7 square roots of x. And then it says evaluate for when x equals 4. So we're going to find f plus g of 4, which would be negative 7 times the square root of 4, or negative 14. Okay, over here we're going to do this f minus g. And that just means take f of x and minus g of x from it this time, which is 3 square root of x minus negative 10 square root of x. Minus a negative means plus. Applying the rules of radicals, that just becomes 13 square roots of x. And then f minus g of 4, 13 times the square root of 4, or 13 times 2, which is 26. So simple enough process, you just have to remember all those rules of how to actually add and subtract these functions. Okay, f of x equals this, g of x equals that. Find g minus f of 2. So we are finding g minus f of x, which is g of x minus f of x, which will be, see, g is listed first, so this time it's x squared plus 6x minus 1 minus f of x, distributing through. We end up with x squared plus x plus 5. And then to find g minus f of 2, that means you can plug in 2 everywhere there's an x. Now, you could have, coming back to here, of this idea right here, g minus f of x equals g of x minus f of x. If you looked at it back here, g minus f of 2, that would be the same thing as g of 2 minus f of 2. Now, g of 2 would be, let's see, that's 4 plus 12, so what is that, 15, minus f of 2, which would be, nope, I did some maths. I can't do my maths. Let's see, that's 4, 2 squared is 4, plus 6 times 2 is 12, minus 1, that's 15. Get myself off track and making mistakes. I must have made a mistake in the other one. It should be 15 minus 4 or 11. I must have made a mistake over here or something. I'm gonna pause on the mistake. What a big dummy. Why do you guys say anything? It's supposed to be 4 plus 2 plus 5, which is where the 11 came from. Guys. Right? I did 4 here instead of 2. So either way would work out fine. I just thought I'd show you a side note. Okay, this one right here, given f of x equals this, g of x equals that. Now this is going to draw on further back memories, good memories, of what the properties of exponents are. So f plus g of negative 27. We need to find f of x plus g of x, which is negative 2x to the 2/3 power plus 7x to the 2/3 power. Now, any rule with variables says you can only combine them if they have the same powers, right? So x to the 2/3 and x to the 2/3 match. I can combine them. Negative 2 plus 7 is 5x to the 2/3. Okay, and then f plus g of negative 27 would be 5 times negative 27 to the 2/3 power, which is, get 5 times 9, which is 45. Okay, now that's adding and subtracting. We also need to talk about multiplying and dividing. Thankfully, it's the same process. If I ask you to find fg, that means I'm talking about f times g. Take the first function, multiply it by the second function. Usually you're going to want to put parentheses in there to keep them separate. And then divide is the same thing. Take the top function, f, divide it by the bottom function, g. That's the one that gets a little tricky because rules for division get a little bit more difficult when you're dealing with different types of functions. So f g of x right here means I'm going to take f of x, multiply it by g of x. Okay, f of x though is negative 3x squared times g of x, which is 6x to the 5th. Now combining those together, when you multiply, you're going to multiply the numbers together, negative 3 times 6, and then you've got x squared times x to the 5th. And hopefully you remember the rules for multiplying exponents. So we've got negative 18x to the 7th power, because you have to add those powers together. Oh, and then it said to evaluate when x equals 2. Okay, so we need to find fg of 2, which will just be negative 18 times 2 to the 7th. Boop, boop, boop. Calculator would give you that number, but it's too big for me to write in there, so you get the idea. Okay, down here, let's do g divided by f. So we're going to take the g function on top and the f function on bottom. G was 6x to the 5th. F is negative 3x squared. Again, properties of exponents. 6 divided by negative 3, x to the 5th divided by x squared is negative 2x to the 3rd. You subtract powers when you divide. Okay, so there's that function. Then when we find g over f of 2, that's negative 2 times 2 squared, cubed, which means this one we can multiply out. Negative 16. So multiplying, dividing, addition, subtraction of functions, all it is different notation that's saying, hey, multiply these two things together, hey, divide these two functions. Division, it matters which one goes first, and so does subtraction. So be careful about which one's on top compared to which one's on top in your actual calculation.